Hello, I'm going to walk you through some simple scikit-learn Python program. So this is actually a Python module for data science, machine learning related tasks. What I'll be using as an editor is Visual Studio Code. You can download it from here, which is free. And also I'm going to use Anaconda. It's a Python distribution package. It comes with many libraries and modules that you can use. It makes your life easier, that's all. To train a simple machine learning model, we need a data set first. So I'll be downloading a simple data set from Kaggle. Okay, I've already decided which one to use, so I'll just try and download it. So we can download this dataset by clicking here. I've already downloaded it in my computer, so let's go and see. Let's create a new folder for our project. Let's call it first machine learning code. Okay, so the dataset that we're using is actually this one. 500 person, gender, height and weight, along with their body mass index value. So I'm going to copy this into this folder, and I'm also going to create a Python file, but not from here. I'm going to use this editor, VS Code. It comes with a terminal, and when you first install it and try to run a Python file, it may suggest you several extensions. They are very useful. I suggest you to install them all. So yeah, they are Explorer. No file is open right now, so let's create a new file. Okay, it's probably creating a new window. That's not what I want. Okay, let's save it in our folder, which has this data set, and let's just call this file code.py. And also in the terminal I am using PowerShell because I'm using Windows, and I have to move my terminal to the folder where the code is. Okay, it did. So if the code is working, let's just try a simple thing, printing it out. You can just type in Python and with a space type in the name of your code file and it will run. Okay, see, it works, so let's jump right into the code. The first thing that we need to do to use scikit-learn to import it, assuming that you have already installed Anaconda distribution, you should already have it. And how to do that, how to install it from Conda or install it from PIP, Python package installation, I guess. So you can just look for online tutorials for that. So I'm going to import scikit-learn. You have to do it that way, import sklearn, and I have autocomplete. That's really helpful. Since we'll be coding a simple built-in decision tree classifier, you can do it also this way too, from sklearn import tree. So if you don't need the entire module imported, you can just do this. For our purpose, any of either would do. And to make our life easier with file handling, I'm just going to import a CSV module. You can see the file we will be using is actually a CSV file, .csv. So I'm going to import a CSV module to get the value from this file as a list of lists or a 2D array. It will be easier for us. So first thing we have to do, we have to take the file in a variable data, and I'm going to write code. Just follow along. I think explaining this bit by bit won't help much right now. So I'm going to copy the name of the file. Also don't forget to put the .csv in the end. And okay, it's in reading mode, So what I'm doing, I did a one-liner. You can do it in multiple lines. So what I did, first I used this open function to open this file as a reading mode. Then I put this function inside csv.reader. I'm using a reader function from this CSV module to convert the entire file into an object of that type. And lastly, I'm converting the entire object into list. So this object is actually a set of lists, and if you convert a set of lists into a single list, it becomes a list of lists, which is another way of saying a 2D array. So you can have list of list of list. I mean, you can have an ND array. That's cool. That's pretty easy. So let's just see if we have gotten the file completely. So let's just print the first row of our array. You can print it like that. So again, go and here Python code. Okay, it prints the first row. So actually we can see the first row is actually the level of the columns: gender, height, weight, and index. So okay, let me zoom out if you're looking at it from a smaller display. So the first row is actually the header. So if we want to train the data, the header doesn't really help us. We need the numerical values. The headers are actually just levels. So let me put that in a different variable. We can just call it a header, and we're going to store here the first row. And now what we're going to do, we're going to remove the first row from our data set. So I'm going to just do this. It's called list slicing. So I'm going to take from row 1 till the end, and the first row is removed. It's not lost because we've already saved in the header variable. So yeah, we can print the first 5 row of data set. Let me try just to have a look how these are. So yeah, male, we can see it contains several lists, Python list, each having 4 variables inside it, and the entire thing is in a list. Now one thing to note, that when you're going to build this an NP array or NumPy array, I think, it can only train on data having numerical value. These are all the strings. Since we read it from a text file, these are all the strings, but these strings 96, 4, 87, those strings can be converted into real numbers with these parsing functions. But there is no way you can convert female or male, this sort of thing, into real numbers. So if you pass a numerical value as a string, that's no problem. But if you pass a string that's really no numerical value at all, these are called nominal attributes. So you can't do that. So what we have to do, we have to have a data set having only numerical value. So what we can do, we can edit the entire data set, which do it that way. So we know we're going to go over every row. Every row will be having this. So let me just print out the row. There will be a lot of rows actually, but let's just give it a try. Hope my computer doesn't break. Okay. I don't suppose it should be this. Let me print out the length of this entire data set first. It's 500. So why is it printing only one row? Okay, now I did well. Maybe I've made some mistakes. I'm new in Python, so we can see every row. They are all numbers except for the first column. The first variable of every list is a string. So what we can do, we can change it. We know the first index of every array or list is index 0, so we have to change it to something else. If row 0 is equal to male, we can do it. We can put here 0. You can also put a string 0, that doesn't matter because it will be parsed in the end. And else we can just put here row 0 1. Actually this way possibly we won't be changing anything from data, because every row is fetched to another variable which is used just to display what is the content. What I will be doing though, this is another type of loop which is called enumerate. It gives you the value just like an auto loop in Java or this type of things, for each loops I think. It also gives you the index. So we know data is a 2D array, so if I print the index just like a regular loop, it should print the loops. It should print all the rows just like before, but this time directly from the data variable. So if we update the data, we can do it that way. So what you can do, if data is male, so we know how to deal with 2D array. There are two, what should I call it, two variables to pinpoint a single index. Okay, that's it. So after that is done, let me print all the row again. So just jump right in. Okay, now you see the data set is edited, so we can see there is no nominal or ordinal attributes at all. Everything is numerical, and the first column, which was having male and female labeled attributes, now they're just 0 and 1. Yes. So I think our data is ready for training. So what we'll be doing, we need to identify the features and the labels. So what we know from the header file, let me just print it and see how this can work. Okay, there's a problem. Okay, I did a typing error. So we have gender, height, weight, and index. It's body mass index, I think. So what you can do, we can take these three as features and index as label. So if we train our data that way, now what we can do, you can input someone's gender, their height and weight, and you can get a prediction of what their body mass indexing could be. So this is our answer we're looking for, the body mass index, given these three attributes. So these three will be our features, which we will provide as input, and this is the output or answer we'll be looking for. Training data will have these things already, and with new inputs we're gonna have prediction. So I should be writing it here though. So let me just define something. So we have a list of features and a list of labels. We will enumerate just because it gives us more options. So what we'll be doing, in the feature list will be append the, I think IDX. I think we don't need to enumerate here. We can just append the first first three columns or first three indices of the list, and for levels we can append the last column or so. So we have 4 columns actually, 0, 1, 2, 3. So everything before 3, from the beginning to 3, we give it to the features list, and the row of 3 or the third column we give it to the levels list. So let me just print features, the first entry of the features and the first entry of the levels, just to see if we got them right. So yeah, level is 4 and this is it. So what we can do here, we can actually convert it into list, because when we're training our data, it all will be given as a list, everything will be list. If you just want to pass a single variable, make it a list. That's how it worked so far, I think. So we're going to create a classifier. We're going to call it a CLF, and we're going to use this module right now. We imported tree from Sklearn, so we'll use a module from tree, and the class name is actually decision tree classifier. I think it's the class, or it is the function what we'll be calling. So this create the classifier. Is there a problem? Decision tree. Okay, typo. Sorry. Now we have to fit the features and labels. Here's the training part will go. So we have to fit the features X and the labels Y. This is the convention of saying these things, but we don't have X, Y here, we have features. So let me just put features and the levels. So let me just see if we got all this correct so far. Okay, nothing wrong here, I think. So if these are okay, let me just print, or let me just do a prediction, clf.predict. Since CLF is our classifier, we just call it with dot predict, and I have to pass it a list of list. I think we have to give it something. Let's say someone's gender is male, so that's 0, as we did it before. Height is 150, and age is and weight is 130. So just print the result. I think if I got this list thing correct, that should print it. So its index BMI should be 5. That's the prediction of our program. So there's one way of predicting. So there's a more conventional approach of training. So we do not put every last one of the training data into the features and labels. We put 80% or 90% or some percentage of the actual data to the features and labels that we train on, and we also keep some data as a test data. So let me just do it here. I think it'll be easier for you to understand if I just code and talk less. So yeah. So I'm not going to put all 500 of the data entry into this. So what I'm going to do, I'm going to again just change it. I'll just row. So again this enumerate loop. So yeah. So let's say we have 500 data, we know that. So anything after 450 will not be inserting them into the actual training data. We're going to include them in the test data. So yeah, and labels test dot append. Yeah, and continue. Yes. anything after 450, everything will send it to the test data. Or you also have to populate the training data, so let me just do that. So yeah, we have this ready. So everything will go here basically in the beginning, and after 450 rest of them will go here, and the continue will make sure that nothing goes into the actual training data after 450. The first 450 will go to here and the rest will go to the test data. So again we can classify this thing. Let me just see if there is any error. So far there is not. So yeah, I think this is already printing. Let me just print it right, the size of data set. Okay, printing doesn't harm it. So again we'll be actually going through this, going through the test data. So for IDX row, enumerate features of test. Yeah. So we'll be iterating from through the test data and check whether or not the prediction of them matches the test levels, because we know for this input the output should be corresponding test level. Let us see if they predict them correctly. CLF predict. So we have to pass it as a list of lists. So we know the feature test already contains list. Well, let me just put square braces so it becomes a list of lists. So yeah, let me just pass the rows because the rows already have the training inputs. Let me put it somewhere in a variable, and if result equal to the corresponding level, and we can just count success plus equal to 1. So we have to declare a variable which will count our total correct prediction. So yeah, also keep a variable just to count the total prediction. We're going to increment this with every loop, and then we can print it, the success followed by total. So yeah, let's run the code and see if it works. So 43 out of 50 training data, 43 prediction was correct with actual levels. They matched with the actual levels. Yeah. So if we run this code again, it may predict differently. Run it again, 44, run it again. Okay, it's always now 43, 42. It fluctuates, but we can see this, it's below 45 and above 40. So we can actually, let me put 350 in actual data and the rest will go to training data. Now let's run the same thing again. So we have 125 correct prediction out of 150. So it's up to you how much data you will put into the training data and how much data you will train the model on. So that's pretty much it. So the things that you need to know about using decision tree classifier. These two lines, these are very important. And the rest, yeah, if you know Python a little, you can do it. My codes are not that great. I'm learning, and they should be better over time. Thank you for listening. Chiare.